In Renewable Energy Technology Laboratory, now we are going to see the experiment on simulation study on Hydel Power. So to perform, the aim is to perform a simulation on Hydel Power system and to study its operation using the Simulink software. The MATLAB R2020 software has been used, and this is the simulation diagram of Hydel power generation. So here we can see that HTC, that is the high turbine generator, and Hydel turbine generator, and this is an excitation system which excites the turbine generator. Here the input will be the reference power, and we will be having the initial reference and pre-reference values, and we have the DQ axis voltage reference as the input for the excitation system, and the input output of the HTG and excitation system has been given to the synchronous machine, that is 200 MVA 13.8 kV synchronous machine. So the synchronous machine rotates based on the here the gate. So by here we can give when the gate has to open, the turbine gate has to open, and when the turbine gate has to be closed. So based on that, the synchronous machine will rotate, and the output of the synchronous machine has been stepped up or stepped down by using a three-phase transformer, and finally it is given to the load. So this is a simple simulation diagram of your wind Hydel power generation system. This will be discussed in the, and this will be the output, simulation output. That is, we can see here the stator current, the three-phase stator current of the Hydel power system. So in MATLAB, once again, by using the Simulink library browser, I can browse the various components and I can place in the simulation window. So this is an turbine generator. So hydraulic turbine and governor. Here we have a servo motor. What is the KA value and TA value and gate opening limit? When the gate has to be minimum limit, maximum limit, and similarly the voltage minimum and maximum, and permanent droop regulators, hydraulic turbine values, beta value, droop reference, initial mechanical power, everything will be given in this input, which has an input block, that is the model of hybrid power generation, Hydel power generation, and here is an excitation system. So the excitation system has a parameter of DQ axis, that is low pass filter time constant, gain time constant, exciter, damping filter gain time constant, regulator output limits, initial values of the terminal voltage and field voltage can be given as an input to the excitation system, and this is given to the synchronous machine. The here I have taken the mechanical input as an input. So here mechanical power is the input. I have chosen salient pole. You can choose round rotor or salient pole generator. Then the parameters are nominal power, line to line voltage, frequency, reactance values, time constant, D axis and Q axis values, stator resistance, inertia coefficient values, initial conditions, everything has been given as input here. And here is a three-phase transformer. So here it a delta star connection has been used, and the parameter nominal power and frequency, winding 1 parameters, winding 2 parameters, magnetizing inductance, resistance values, saturation values can be given as input. And this is the three-phase voltage source, which here it will be connected to the grid, right? This is the load. So here the what is the value of the phase to phase RMS value, and this is the three-phase load. So what is the face-to-face voltage? We can see three-phase parallel RLC load has been used. So the Hydel power turbine generates the three-phase load. And from here, I can see the stator current in per unit, and output reactive powers and everything can be seen here. So here I will be, here is a run button. If I run the simulation output compiled, so there is no error and the time starts to run, the simulation starts to execute. So here I can see the output of the turbine generator. So that is the stator current of the turbine generator. Since it is simulating, it is keeping on moving. So once the simulation completes, you can see the final three-phase output of the three-phase current of a turbine. So similarly, I can see the voltage values, how it is simulating the voltage value of a three-phase generator, Hydel power generation, and the voltage of the excitation system. Then speed of the turbine, we can note the speed of the turbine by the having this Likewise, we can see the various parameters of the Hydel power generation. Once the simulation has been completed, now we can see the values. Here there is a graph. So if for extending, I can extend. So this is the output voltage of your turbine. So it is a pure sinusoidal wave, right? So I can see the output of the turbine, and here I can see the stator current, that is the three-phase stator current as the output of the Hydel power generation. This is a simulation diagram explaining how the power has been generated by using the Hydel power and what will be the voltage and the stator current of the Hydel power generation.